Hey everyone, my name's Amelia.
My name's Lauren.
And my name is Karen.
And today we're going to speak with you about the basics of
Sustainability.
And don't worry, we'll keep it light. So at this point, you're probably asking, what is sustainability? Sustainability, at its core, is the ability to maintain the healthiest possible environment for not only people, but all living things. As it relates to architecture, engineering, and construction, often referred to as the built environment, the ultimate goal is to achieve the most efficient and least disruptive use of land, water, energy, and resources. Sustainability has 5 basic principles, which is essentially how we're going to outline our lesson for today. First one being site potential. Next is water conservation, energy conservation, quality of indoor environments, and materials and recycling. All right, jumping into the first principle, being the site. There are a number of features by which a site can be evaluated, but I'm just going to name a few. First, we have protect or restore habitat, and that is to conserve existing natural areas or to restore any damaged areas to provide habitats and promote biodiversity. Another one here is rainwater management. And that's essentially whenever you're capturing rainwater from roofs, local streams, storm drains, etc., to then be reused in many ways. Third one here is heat island effect, and that is the buildup of heat within an area, let's say a city, where the materials selected are actually to blame for that heat buildup because they're actually absorbing and letting off even more heat, which is causing that entire area to be unnecessarily at a higher temperature than surrounding rural areas. And then lastly here we have light pollution, and that is actually the presence of artificial light at night, which can actually over time just negatively impact nature's fundamentals. Another consideration of a site is its location, which is based on its relationship to the sun and the equator. Whoa! Whenever you understand its location, you can actually better understand the climate, which is extremely important to design around. So for example, with your site in particular within North Carolina Zoo, it's important to look at it from multiple perspectives. So first, a zoomed out lens, commonly referred to as a macroclimate, which can give you an understanding of the weather, the surrounding sites, such as the Americas, Asia, Australia, Africa, and Antarctica, as well as the resources that are nearby. Next, you'll actually look at it from a more zoomed-in lens, commonly referred to as a microclimate. This is where you can actually start to get an idea of how a building should be oriented. So understanding both the macro and the microclimates will be essential once you get into determining which sustainable features you'd like to incorporate into the design of your building and site components. Following site principles is water conservation. It has an obvious goal of just trying to reduce the amount of water that you use, but there are a number of methods and ways put in place to help you do so. One method in particular is to capture rainwater. The example on the right is a diagram of the Oregon Zoo showing how they sloped their roof so that when it rains, the roof is actually directing the water to a location to be collected, reused, and recycled. Another method is to use efficient fixtures. The image on the right is something we're all pretty familiar with, a faucet. But what you don't see in the design of the faucet is that it's built to actually slow down the amount of water flowing from the faucet. Lastly, and almost most importantly, is regular maintenance, which will allow you to pick up on leaks that may occur. It will actually provide a longer lifespan for your fixtures and even reduce your monthly costs. For this next slide, I want to go back to the idea of how much of an impact using low-flow fixtures will have on your overall water usage. Keep in mind, low-flow fixtures don't always have to be faucets. They can really be almost any plumbing fixture. Let's say a toilet, for example. If you flush a toilet, let's say 30 times a day, for a year, you'll actually use about 66,000 gallons. As opposed to if you use a low-flow toilet, you will use about 18,000 gallons a year. That's about a 73% reduction in just 1 year. That's crazy! Now let's look at a building type we all understand, a house. The diagram on the screen shows an example of a number of water conservation methods all working together. You can even see some of the solutions and systems we discussed earlier. from a sloped roof directing rain to a location to then be reused in a garden, to efficient fixtures throughout the house, and even someone performing regular maintenance outside. It's pretty cool.
Thanks, Amelia. Now, it's not just water we can conserve. There's energy, too. I'm sure y'all can guess there are a ton of ways we can conserve energy by using things such as renewable energy, efficient or smart fixtures, and by doing something as simple as regular old maintenance. So what can renewable energy look like for your site? Let's take a look at these panels. PVs are photovoltaic panels, not to be confused with solar panels. Photovoltaic panels convert thermal energy into electricity, while solar panels convert solar radiation into heat. One is not better than the other. They actually complement one another, which means you may want to use both. We can see examples here doing both. In a parking lot like the Cincinnati Zoo, they replaced the need for trees creating shading as well as street lamps. In a park in Israel, they're creating both shade and in the evening light along the path. They can be used to create energy needed for parking meters, lighting for bathrooms, or heat in a public space like a learning center. Singapore has gone as far as to create super trees of renewable energy. These nearly 150-foot tall trees in the gardens of the bay have vertical gardens, connector paths, and solar panels on top that create lighting shows in the evening. I highly suggest you take a look at these. Environmental sustainability was a core design principle for the gardens by the bay. Some of the trees even serve as exhaust for other parts of the garden. Which takes us to our next piece in energy conservation, HVAC. HVAC is your heating, ventilation, and air conditioning. This means how warm or cool you keep your building or your house, and what the airflow is like. This combination of items is the largest consumer of energy within a building, and as you can see here, an inefficient system can add up to 45% of your bill. So how do we get around this? One way is to, as we breezed over earlier, use thermal energy. Another is cooling through passive ventilation. The image at the bottom right hand of the screen shows how a habitat can do this. The building has a very sculptural roof that doesn't just act as a roof, but it's built at a specific angle to block the harshest sun, but also collect that thermal and solar energy to transfer into the building. There is ventilation at the soffits to allow airflow to move through the space, and an added bonus is in the lower caretaker space. It is easy to store items that need a cooler environment without needing air conditioning because it has natural insulation. Now on to electrical. Lighting is getting smarter and smarter every day. But what does that mean? It means we integrate solutions such as daylight harvesting, occupancy sensors, or power over Ethernet lighting. Daylight harvesting means using a sensor to gauge how bright a room is, or the photometric amount of light, to set what percentage a light should be on and its brightness. So, in the summer mornings, the light may not be on at all, or at something like 10 or 20%, whereas on a winter morning, it may need to be at 90% brightness. Think about how your phone changes brightness of its display in the day versus the night. Occupancy sensors turn a light on when you're in a room and off when no motion is detected. You can't tell me you've never been in a bathroom when the light has turned off on you. As for power over Ethernet lighting, it essentially captures both of these into one efficient solution while being remotely controllable by an app. Now, your site won't just have indoor lighting. We need to consider exterior as well. Now, have you ever stood downtown Raleigh, looked up at the sky, and you can barely see a single star? But when you drive out of town, where there's far less buildings and peoples, and all of a sudden there's stars around? That's due to light pollution. We as humans are pretty sensitive to it, which means animals are even more so. They follow a circadian rhythm that tells them when to rest and when to be awake, and it also tells them when and how to process their food. Because of this, We want to be extra careful on how we place lights around the animal, making sure that they have enough space that is dark for them to properly sleep and rest without interruption. That isn't to say we don't want any sight lights, though. We still need our habitat to be safe for humans to walk. This means looking at things that are low to the ground and have not so much glare. With all these lighting and electrical considerations, we can also look at whether or not we truly need lighting in a space. There are phenomenal ways to bring natural light into a building, such as with solar tubes or skylights. Some of you may have been in the NCMA and not even noticed that it's mostly naturally lit. It's only in the evenings that they really use their track lighting. Now, all of these items I've been discussing, between our HVAC, our electrical, the lighting, energy consumption, it all comes down to creating a good quality environment. Are we shaded? Can we see? Is it too bright? Too dark? Am I hot? Am I cold? Do I need some fresh air? If we are in a quality environment, we don't even think about a single one of these questions.
So now we get into what exactly is used to construct the building, materials, and how they are used. There are a few things to consider when selecting your materials. First, we want to be aware of where these materials are sourced. The closer they are to your site, the less expensive it is to transport, and it also has a sense of belonging to your design. Something made with mostly local materials can better relate to your site. We also want to consider the life cycle of the material. We don't just focus on where the material is going on the building, we also want to focus on where it comes from, how it was made, what will happen when the materials need replacing, or even when the building needs demolishing. Next is prefabrication, which means the materials are made off-site at a facility and then transferred to the building site. One big advantage of this is less disruption of the site and even less waste produced in the production process. And lastly, choosing rapidly renewable materials like the eucalyptus fencing we see here. These include materials with a harvest cycle of 10 years or less and generally result in lower environmental impacts. One big responsibility of construction teams is to monitor how much waste is produced during construction. So you've probably seen big dumpsters like these at construction sites before. Since it's still fall and not too far past Halloween, imagine one bag of M&Ms. We get to eat all of those M&Ms on Halloween, but we also have to throw away the wrapper that they came in. Now imagine that each M&M is wrapped in its own wrapper, and now picture that at a building scale. Every piece brought to construct a building comes in some sort of packaging, and that can make a lot of waste. So the contractor has to make sure it is safely recycled or disposed of. Here we can see how a single building can use many different sustainable strategies. Trees and roof overhangs are used to control light and shade where needed. Gardens, pavers, and roof slopes are used to control where rainwater goes and is kept away from damaging the building structure. Insulation, passive space cooling, and reflective roof colors are used to maintain occupant comfort and reduce energy levels. So how do we determine how green a building is? There are a number of organizations that have developed rating systems for this exact purpose and recognize sustainable and high-performing buildings. Some of the more well-known ones include LEED, Energy Star, WELL, BREEAM, NGBS Green, Green Globes, and Living Building Challenge. The main one we will focus on is LEED, which stands for Leadership in Energy and Environmental Design. LEED certifies buildings through a system of credits that earn you points towards certification. There are 4 different levels: LEED Certified, LEED Silver, LEED Gold, and LEED Platinum. And here you can see the range of points needed to achieve each certification level. The way these points are certified is by rating a building according to different categories. These categories include location and transportation, sustainable sites, water efficiency, energy and atmosphere, materials and resources, indoor environmental quality, innovation, and regional priority credits. Here is an example of how a project would be scored with the LEED checklist. The categories we just discussed are listed here, and the columns are used for the project team to decide if they are going to pursue a certain credit or not. At the beginning of a project, you look at all the different categories for your building, and you can decide if this credit is a yes, no, or maybe. Then you tally all of those points and see which certification level you will achieve. Let's check out sustainable sites as an example. This category has one prerequisite, so one required, and then 6 possible other credits that have varying point levels to them. On the right, you can see that site assessment has a possibility to achieve 1 point, but site development has the potential to achieve 2. All of these credits have additional descriptions of them listed on the LEED website if you'd like to learn more. So this week's activity is going to involve every group taking a stab at filling out this checklist and just see where your current project falls. Then as a group, you can discuss which level of LEED certification you want your building to target. Certified, silver, gold, or platinum. This may seem like a pain, but think back to all the ways sustainability can benefit your building's users and our environment. It is such an important part to include in a project, and this LEED checklist is just one way to help make that possible. As always, reach out to your mentors for help, and thanks for listening.